state, which is just at the end of that non-canonical blockchain, on your local node. Then the idea is that as being part of the peer network, you will eventually be propagated the canonical blocks and the longest one, the ones that form the longest chain, and you'll update your state and you'll end up with the right thing. So then the question is, well, in that meantime, won't I get the wrong answer? The answer is yes, you might get the wrong answer. But it will probably, propagation times are pretty quick because we have a well-formed network, so that wrong answer might last maybe a half a second.
But but your JavaScript, then you may need to plan for that.
That's correct. So the way that would be planned for is placing these events would refire, and so you would get you should never assume that things are incremental. You should always actually check the state and use the events only as a way of knowing that these events have gone off, but not necessarily that they are sort of accumulated onto your previous state, because that state may have been rolled back. Now, it's actually less of an issue than it might seem, because on-call blocks, though they're less rare than in Bitcoin, they're still quite rare. And then as a client on the network, they're unlikely to propagate very fast. Sorry, not on-call blocks, orphan blocks.
Why would it be less rare?
Less rare?
Yeah.
Because the block times are considerably lower, and therefore orphan blocks are generally they're basically a ratio of the block time with the propagation time on the network. So one thing that we've done to sort of to make that ratio more or less the same as Bitcoin is to have a very well-formed network. So we use the Kademlia protocol in order to make sure that nodes tend to be about the same distance from each other, and so propagation is basically just log n of the number of nodes in the network.
But if the mining difficulty increases over time, wouldn't then that time increase?
So the mining difficulty would increase or potentially decrease just in order to keep the block time the same. So it hasn't an effect on the propagation time.
Do you know what the block time is?
The block time we're targeting is, well, it's phrased in a slightly different way. We want around 5 blocks per minute in total, and that includes any uncall blocks. So if, hypothetically there were no uncall blocks, then it would be every 12 seconds. If there's one uncall block a minute, then it will be every 15 seconds. So
you were committing to a number and putting it by a block number, and then another contract is the lotto, which is the play card, and that has the function that claims supplies, and that's the contract.
That would be the same contract.
Can you repeat?
The question was, would they be different contracts that handle the staking and the claiming? That's correct. So they would be the same contract because they would both need access to the same data. So the data is stored in a single contract in this ticket mapping. I mean, this is mapped into the contract storage. Yeah, so it's all looked after for you. You don't have to worry about any of this stuff. You just get this nice abstraction.
So Bob, if puts in a number, says he commits to a block, and then the lotto contract is run against that.
So Bob places a bet, right? So he records his bet, his assumption, if you like, with the contract. And at the second phase, he then checks whether the future event is effectively concordant with his bet. But the way that we do it is we just to confuse you all, basically. We're also using a commit reveal process, so that rather than saying what he actually thinks, whether he thinks it's going to be even or odd, we're actually saying it's the hash of a number of whether he thinks it will be even or odd. So the reason I'm introducing you to this is it's quite an important way of operating with the blockchain. So one of the things that when you start doing decentralized app development, one of the things that you have to start really thinking about that you never think about with any other type of development is incentivization, right? making sure that when people interact with the system, that their incentives are aligned with what you expect them to be. So in this case, if I hadn't have deleted the tickets, right? If I had just like, you know, don't bother with cleanup, they can clean up some other time later, then if this was some sort of like, you know, closed sourcey thing, it wouldn't matter, because the front end would just would automatically check to make sure it wasn't double claimed. But because we have something that is, you know, fully autonomous, and we can separate out the front end and we can interact with the contract directly, the actual incentivization is just obviously just to keep claiming, right? It's a really bad bug. It's like, you know, a terrible bug. It would completely bankrupt the contract, and we wouldn't be able to correct it because we can't alter the code once it's there. So it's very important that we consider very carefully what the incentives are for the people. Now that's a really obvious one, but there are many more subtle ones. Consider what happens if Bob never claims, right? Maybe he. What do we do if he claims in you know 5,000 blocks or 60,000 blocks? Do we want to allow him to do that? Maybe it costs us to it doesn't as it happens, but it will do in the future. Maybe it costs us to keep information in this contract. What happens if Bob realizes that he hasn't won before he calls, because he just does it on his dry run system, and he says, well, I'm not going to call that, it's only going to cost me money to claim that I haven't, to claim nothing. Yeah? Because by running these things, by sending transactions on the blockchain, you have to pay. Right? They're not for free. You have to pay gas. You have to pay the rest of the network to authenticate it and to archive it and to execute it and to check the form a consensus. So if Bob knows that he hasn't won, then with this code as it stands, he will just alter the front end so it never calls, and it doesn't waste that bit of money doing the cleanup. Yeah. So as this stands, this has got a subtle incentivization bug. The cleanup will never happen. That's bad. As it happens, that's paid for by the rest of the network rather than the contract owner, but it's still bad. The way that you do this, the way that you try and, one of the tools that we can use to align incentives with that which we want is security deposits. So one of the things that we could do is make Bob, in addition to his stake, also put down a deposit for being nice, right? Cleaning up after himself. Yeah. So imagine this is like the when you go shopping. I don't know if you do it here, but in Germany when you go shopping and you want a bottle of soda, they sell like the old style glass bottles there, and you actually, part of the price is like, I don't know, like 12 cents for bringing the bottle back. Well, that's how you incentivize people to actually clean up after themselves, right? So we would do the same in this, and there's actually another example in the repositories of a more fleshed out version of this, where we do incentivize. We take a small deposit off from their stake, and if they lose, then we give it them back for cleaning up after themselves, for calling clean up. Yeah. So it's very important to consider. Because people can interact with your contract however they choose, as long as it's through your interface, basically however they choose, they can give it any inputs they want, they can call it whenever they want, they can, as long as they pay for it, they can transact with it however they like. This is not behind any security firewall, right? The blockchain is a public ledger. As long as you play by the rules, which is to say, run the code faithfully, you can do whatever you like. So it's very important that there's not something that you can do which in some way advantages you against everybody else. And you have to think about that very carefully when you're designing these things.
Maybe after a break, would there be interest? Would you have time to do Hello World so people could set up a developer environment and just get something started? Because you won't be here next week, right? Yeah. Back in Berlin, unless you want to go to Berlin. You have somebody to learn to Hello World. If that makes sense, I don't know. Yeah. Is there consensus here? Yeah. So like 10-minute break, and then we'll do Hello World at least. And
okay, so Vitalik told us to eat cake.
Oh, and you can eat your cake too.